Hello everyone, welcome to Data and AI Summit 2022. I am Rohan and with me is Philip, and we are here to give you an introduction to Presto and share the product roadmap for a Presto project. So just to introduce myself, my name is Rohan Pednekar. I worked at Ahana as a product manager, and I am also the chair for conference program within the Presto Foundation, and I closely work with Presto community and its users. So let's get started. Presto is very popular open source project, but today I really want to discuss why it matters and why Presto is the SQL engine for the data platform teams for both interactive as well as batch workloads. So let's quickly revisit what Presto is. Presto is a disaggregated, distributed ANSI SQL query engine originally designed to replace Apache Hive um, to achieve scalable interactive queries across large data sets as well as across different data sources. So Presto created at Meta, and now it is very popular open source project among others listed under Linux Foundation with the Presto Foundation. Today, at the internet giants like Meta, Twitter, ByteDance, and Uber, Presto runs at massive scale and can analyze petabytes of data. So here is the quick overview of a Presto cluster. It's a distributed system of coordinators and workers, where coordinator is responsible for query planning, query scheduling, etc., and the worker is responsible for performing the work on across different data sets, different partitions, different splits, all in memory. So as a user, you can connect to the Presto using a JDBC or ODBC protocols with any other reporting tools that have shown above. You can also use notebooks like Apache, Zeppelin, Jupyter, etc. to access and analyze the data. On the bottom, you see you have a data lakes like S3 as well as a range of other data sources like NoSQL databases, relational databases, streaming data sources like Kafka, caching system like Redis, and real-time data sources like Pinot, Android, etc. So these are some of the common questions we often get asked. So let me talk a little bit more about this. Presto essentially is just a query engine. So if you think about a more traditional database, it comes with compute and storage together versus Presto, which is really just a compute and it runs on top of storage, which might be your database or your data lake, or it is just a part of database, which is the query engine. Also, it comes out of a Hadoop ecosystem. So the way it requires configuration management, it depends on Hive Metastore, and in that it is related to Hadoop. However, it has its own system, so you do not need Apache Zookeeper or any other components of Hadoop. If you are querying your data lake using Presto, then you just need a Hive Metastore as a catalog or any some other kind of a catalog like AWS Glue, but you do not again need any other components of Hadoop. And given that it is just a query engine, it also different from the data warehouse, where the biggest advantage of a Presto is you can query data in place. There is no need to move it or ingest it yet into another system or copy it. So here is what Presto makes different from some other engines out there like Spark. Spark was built to be a different general purpose computational engine versus Presto, which is meant to be a SQL engine. It is highly scalable. It has a pluggable architecture with a range of connectors that you can use with, and it's built for performance. It is built to be an in-memory engine with a pipeline architecture. So let's quickly take a look at the scalable architecture. So as I was mentioning earlier, we have two roles here. We have a coordinator as well as we have a workers. The workers are connected to the data source and they operate on top of a data, and they can push down predicates where clauses down all the way to the data sources depending upon the connector. In case of a data lake, the Hive connector is used and predicates can get pushed pushed out so that you can read a little as less information or as less data as possible and pull it in into query engine to actually process it in memory. So Presto is highly scalable. A very large number of workers can be supported, and now with the advancement of multiple coordinators, it gets even more scalable. So now let's take a deeper look at the architecture, and if you look at the coordinator itself, it includes some of the typical components that you could expect out of a database. You have a parser, you have a compiler, you have analyzer, that's the optimizer, and this optimizer decides on what plan is more efficient and should be executed on, depending on the stats and other information. And then you have the scheduler. It will then schedule the queries across different workers. And then the data location API tells the scheduler where this data is actually located. And then the metadata API gives coordinator information about tables, the columns, the schemas of the data lying underneath it. And this might be via Hive Metastore or or through some of the other traditional catalogs in the relational databases, which are built into the system itself. And at the bottom, the different connectors connect to all range of different data sources. So now let's talk a little bit more about connectors. Presto comes with about 30 different connectors. Here are some of the most popular ones that we often see in the community. And all these gets plugged into Presto. Presto allows for a query that can be joined across different data sources. So you can correlate relate data across different data sources. You just have to define the schema name appropriately in the query itself. And for every connector you create, you have to have a catalog explaining to the system how it is interact with it, and a schema for how the data should be organized once it is brought in. So a few concepts here. You have a connector which allows you to connect to a different data sources into Presto. The catalog which contains the schemas and the different data sources. So every data source that you connect to the Presto have to have a catalog dot properties defined, and this property file contains the information about configuration of the data sources like endpoint URLs, credentials, and many others, range of different configuration information. And then the schema itself, table are organized into schemas. Tables themselves have a columns and rows, and Presto analyzes this data using columnar approach. And so here, if you here you see if you are working with HDFS or S3 connector, this is how Hive connector works. That coordinator talks to the Hive Metastore as an example here, and it could be a Glue Metastore as well. And then the splits are then assigned to a different workers by the scheduler, which then goes and gets the information from the data lake underneath it. So with the different data sources, Presto also allows different range of data types and different data formats to be queried. So what we recommend oftentimes is Apache ORC or Parquet formats, because those are the most efficient, most performant, and most compact formats out there. But you can query data that's in JSON or CSV and a range of other formats. The beauty of Presto is you do not have to ingest or make a copy of your data yet into another system. It can be queried directly where it lives in the data source. So why Presto? Why is Presto fast? We often get this question. So when you compare Presto with other traditional engines like Hive, we see anywhere from 10 to 15 times faster performance with Presto. And the primary reason is Presto is built as in memory engine. And while you can split to disk if your data that you are processing is larger than the size of a memory allocated, most of the time and most of the deployments we see users size their clusters to the amount of a memory that is needed to perform those queries. And so given this is very fast engine, it pulls the data that it needs and it streams, as it is a stream based, into the memory as it is reading, and it processes it and then moves to the next step. It is also columnar execution that makes it very well suited for the analytical queries. And at the end, recently we announced, not recently, since last year we announced multi-level caching with Raptor X that allows users to enable caching at the different levels. Like user can define caching at the metadata level. Users can configure caching at the metastore level. User can configure the caching at the files, footer, and header level. Also, users can configure the caching at the data block level, and this improves the performance by 10x at the production workloads. And this is how the life of query looks like. If you look at the explain plan here, you see the different operators that are part of the plan. This is a simple plan for a select star from the orders table with the simple predicate. So you have a scan operator which reads data from the orders table underneath. A filter is applied and then the output is returned to the client. This is slightly more involved query plan here. So you have a couple of projections. You have aggregate, which is the sum. You then have a left join on line item and orders tables with a order key. Then you have a where clause, where clause on the order key, and you have a group by and so on. And then the plan. You have a scan operator on the line item, you filter it out, then you scan on the orders table, you see a left join, and then this gets aggregated, and then projections are pulled out, and then the results are returned to the client. Now let's talk about some of the use cases of a Presto. So far, what I have covered is what Presto is, the architecture of Presto, why it is so fast. So now let's talk about how users are using it. And these are some of the typical use cases that we see in the community. So this is the most popular use case of a Presto, that is reporting and dashboarding, and this is what a stacks might look like for it, which is very similar what we discussed earlier. You have a BI reporting tools connected to the Presto cluster with a JDBC driver or a ODBC driver, and you have a metastore, either it's a Hive a metastore or AWS Glue connected and act as a catalog. For your data lake like S3, and you also have a data sources like RDBMS that you can query with. With the Presto in a reporting and dashboarding use cases, another popular use case is data science. You might have a Jupyter notebook. These are the SQL-based notebooks where you might use Python and the Python SDK on top of a Presto to connect to the data lake or the relational data sources underneath it. And within the last year or two, Presto has been used for a batch workloads as well. Examples of a data engineering workloads that are being run on Presto are ETL workloads, and one of the technologies underneath is Presto-on-Spark. Presto can now run as a layer on top of your Spark jobs and allow you to run more robust and reliable batch workloads. And Philip will talk a little bit more about this topic later in this session. And there is also a whole session on Presto on Spark from Intuit. So please do check out that as well. And finally, as cloud data warehouse is becoming more cost prohibitive and data mesh or data federation approach is not performant enough, more and more workloads are migrating to data lake. If your data is going to end up in the cloud native storage like Amazon S3, ADLS, etc., then the most optimized and efficient data strategy is to leverage open data lakehouse, which provides more flexibility with a zero vendor lock-in. It's not anything different from the data lake again. What it means is that some of the capabilities of a warehouse are now being moved to data lake, and one of those is transactionality. And this is achieved using technologies and projects like Apache Hudi. Delta Lake, and others. And Presto is a SQL engine that sits on top of the cloud data lake that you could query with. And this is the architecture of a data lake house that is emerging, and we are starting to see this more as well. And finally, a little bit more about Ahana. I work for Ahana. We are the Presto company. We have a strong database and Presto experts, and we are the premier member of Presto Foundation. And the product at core is a managed service for Presto. It comes with a SaaS control plane and a managed service where we bring compute and Presto to your data in your own account. It is in AWS. A single pane of glass allows you to manage multiple Presto clusters, fully integrated and cloud native with the security features like Apache Ranger, etc. And with that, I handing it over to you, Philip. Thank you.
Thank you, Rohan, for that summary of what Presto is and where it can be used. Hi, I'm Philip Bell, a developer advocate at Meta, focused on big data open source projects. I am also a Presto Foundation board member and will be talking to you about the future of Presto. I'd like to review Presto's roadmap, specifically recent accomplishments and the direction we're taking Presto through its next evolution. The current roadmap can be summed up as Presto for all. Presto is a top-tier interactive query engine. It can unify various data sources in your existing architecture and provide a consistent interface for gaining insights from your data. The Presto Foundation's vision is that Presto will become an effortless experience for many large-scale and complex data-related use cases. We want Presto to be the default choice for reporting and dashboards and to effortlessly handle both quantity and shape of queries dashboard tools might send to Presto. We know use cases range from daily to quarterly checked metrics, as well as queries you may want your BI tool to perform. We want Presto to be an even better ad hoc interactive query engine performance-wise. We're aiming for Presto to be able to efficiently serve data without having to transfer it from your warehouse. This means handling extremely high queries per second, such as externally served requests, with minimal data migration to other storage solutions. Essentially, we aim for adding Presto to your ecosystem to be the only major change needed to utilize it in your architecture. Recently, we've been finalizing the ability to handle large batch workloads with ease. This has been challenging because Presto is an in-memory query engine. Most importantly, we continue to consolidate on the same language to accomplish all of this, with similar ETL and a unified storage backend. The reason for this is the more tools you need to support these use cases, the more complicated and expensive things get. Ideally, Presto becomes a single addition to enable a wide variety of use cases within your organization. So the big question is, what are we doing to help scale to fit these different workloads and support them effectively? First and foremost is to add more connectors. Connectors are a seamless way to get Presto to plug into other data sources and open up new use cases. A quick path to accessing data in an unsupported data source is creating a connector that uses a manifest file through Hive. Over time, we aim to migrate all connectors to being native so that they have better performance and reliability. Most recently, we completed a native connector for Delta Lake that is read-only and a connector for large sheets. Coming soon will be write support for that Delta Lake connector as well as a native Hootie connector. Next, we have to solve for workloads that don't fit within Presto's memory limits. We've put in a lot of work adding more operators to participate in spilling, to configure where the spilling output can go, and to allow customizable strategies to be used. Next, we have workloads that span time rather than just space, surpassing minutes into hours. Presto originally has no fault tolerance, and this must be overcome to support these use cases. The ultimate goal is to prevent the need for rewriting the query in a different engine which may have different semantics or different function support. That's why Presto has migrated its engine to a library that can run on Spark. By leveraging Spark's resource management, we can enjoy the benefits of disaggregated shuffle and recoverability from Spark without having to rewrite your query. Finally, at the opposite end of the spectrum, we have Presto being used for online analytics, something that may be customer-driven. We want to use the same query engine here as well. We've put in lots of improvements in Presto's catching architecture. With the completion of the RaptorX project, Presto now has intelligent tiered catching, resulting in similar performance to having co-located compute and storage. This means you can operate using your existing cloud storage provider without any additional ETL. Adding materialized view support using standard SQL eliminates the need to repeatedly calculate metric rollups or creating pipelines for derived tables. As much as we are working on growing the breadth of use cases Presto can help with, we're also investing heavily in ensuring Presto is even more efficient, reliable, and scalable than it is today. We've completed implementation of disaggregated coordinators, eliminating a single point of failure in query execution, as well as increasing scalability. We've improved scheduling using bin packing, reducing hotspots and failures. Just as important as reliability is efficiency when you're working at Facebook scale within Meta. One path to efficiency is native execution. We are finalizing migrating workers from Java to C++. This grants us better control over memory and instructions utilized. Early performance tests are showing significant orders of magnitude increases in throughput for certain use cases. Our ARIA efficiency work adds expression pushdown all the way into the scan, and we're growing that to include Parquet files. Our third focus of extensibility ties into empowering a wider set of users to take advantage of Presto. One way of accomplishing this is SQL function support, which allows sharing complex mathematical expressions or other complex functions you can encapsulate. Lastly, we've added the ability to query external UDF servers for function execution, enabling users to support languages that are hard to port to Java or standard SQL. With this feature set, users can point functions to external servers either for specificity or utilizing other compute resources for particularly heavy functions. If you have any questions, don't hesitate to reach out on Slack or Twitter. I hope to hear from you soon and look forward to seeing what problems you will solve using Presto.